So you want to dip your feet in the world of AI. In this video, I'm going to walk through exactly what even is prompt engineering, why we use it, and the two fundamental techniques I use when building custom AI solutions for my clients. Let's get started. So fundamentally, prompt engineering is the discipline of crafting an input prompt that makes the LLM do what you want. That's all we're trying to do here. AI can do cool stuff. I want it to do this very specific thing 100% of the time. If I'm building a chatbot out, I want that chatbot to only answer questions about that store, understand the return process, and take care of the customer. I don't want it to do anything else. And the reason why this is kind of an issue, the reason why this whole discipline started in the first place is because prompts are not deterministic, right? What that means is there's no right answer. Like I can give the same input to ChatGPT, for instance, and it can give me two wildly different answers, even though I put in the same exact thing, right? So it's not like if I get this input, I get that output. It's not 100%, it's not one-to-one, right? Like they say in math. Our goal with prompt engineering is to get it one-to-one. Our goal is every single time, no matter what a customer says, no matter what you say, it's gonna do what we want it to do. That's what this whole engineering, that's what this whole discipline's about. And so creating good prompts requires experimentation and practice. There is no one way of doing things, and that's called no free lunch, right? Like in statistics, you can have two wildly different models with different algorithms, but they can yield similar results, right? And so like prompting is very similar. I can have two prompts with dramatically different approaches. One could be like a persona based, and another one could be just like give me like straight up instructions and super clear and concise. Both can give me the exact same result, right? It's just a matter of finding the right one. That's all this is trying to say here. And so two prompts can achieve the same task with dramatically different approaches. The underlying problem with LLMs is that they're non-deterministic, so same input doesn't guarantee same output. So our objective here is to reduce the determinism to determinism so that no matter what kind of input the customer gives or you give, we're guaranteed to get the right answer. So it's a little theoretical here. Let's get into the techniques and be more concrete. Technique one is zero-shot learning. Right? And like zero shot, what that really means is that the LM was not provided any previous examples of the task you're asking it to do. It's like directly just telling, like a human, like an assistant or something, like just do this thing and don't show the person how. So write a recipe to make mac and cheese. That's it. You're already doing this if you're using ChatGPT. Like not every time when you're prompting ChatGPT do you give an example and then be like, and then do this thing, right? Sometimes you might. So that's all zero shot learning is. And a key there is that the word learning, zero-shot learning, does not mean we're training or teaching the LLM through our prompt. The actual training is still done during the model creation process. That's like the expensive thing that OpenAI or Claude or Mistral does for us in the back end using the GPUs. When we're prompting this thing, the LLM is learning what you want the input prompt to be, right, and answer accordingly. So there's no actual learning here. It's a bit of a misnomer term. The LLM is just learning what exactly is it you want and accordingly answering. That's all that really means. It's a key difference that you need to keep in mind, right? Like the learning that you're thinking of in traditional machine learning of like a model or like an AI learning about a data set, that is not what we're doing here. Technique two is few shot learning. So to get a more templated response, opt for few shot learning. This is where you provide previous examples on what you want the LM to mimic. This is extremely powerful when you require the output to be a certain format. So that's just a lot of mumbo jumbo for saying that if we want the LM to kind of model something or if we want to provide more information and it's too hard to spell out one by one, like for example, I can either give it an example or I can say, give me a bullet pointed list. Start off with verbs, add some adjectives, but keep it concise. Like there's so much like little things here. It's much faster, it's much quicker for us to just give it an example of what it is that we're expecting and then ask the LLM to just mimic that same format. So if I give it, this is the format that I'm expecting, when I ask it to give mac and cheese, it'll give me a very similar format of the numbered bullet points, the verbs, the length of the actual sentence. Right? There's so many variables. It's very hard to kind of define in words, but it's easy to just give an example and ask the LLM to mimic it. So that's all we're trying to do here. The benefit here is the LLM can see what type of output you're expecting. It's a lot easier to give an example of something that it can be explained in words. So we'll cover that. I guess note here, this technique used to be frowned upon because it introduced bias in the output. So you probably already know, right? LLMs are autocorrect machines. And so if I put this in my input, right, and the whole point of this is to predict the next output, by definition, it is going to be biased in terms of using words like this because that is what was in its memory, right? Like that's what's going through the transformer, which is just fancy words for saying if it's been seen before, there's a high chance of that word coming again. And so that was a big deal, I would say like a year ago when the parameter size was like 8 billion, 10 billion, maybe even 30, 40 billion. And the variance, like you could clearly tell if I put in this recipe here and I ask this question versus if I just do write a recipe to make mac and cheese, the words were definitely influenced by what is over here, right? And like this was statistically proven in research studies. Now I will say nobody really cares that much. Like the model size has gone from like 8 billion to like 800 billion, right? Closed source, we don't even know how big OpenAI is, GPT-4 or whatever new models came out as. So the final section is art no more, right? Like you know the saying, the art of prompt engineering, or like the science behind building the perfect prompt, crafting the perfect prompt, whatever that is. There was a time where prompt engineering techniques made a difference, right? Like AI engineers, I had to consciously choose between the different techniques. I had to like go between the 10 different techniques, try all 10, and then see which one works the best based on my test cases, right? In 2024, the models have become smart enough to the point where anybody can build a half-decent prompt. The reason I'm telling you this is because you'll see videos that give like 10, 20 different prompt engineering techniques. And although it might feel good that like, oh, I'm learning all these things, realistically, if you're building an actual AI application, or even if it's personally, right, you're probably just going to stick to one of these two. And even these days, there's models, there's LLMs that build prompts for you for another LLM, right? Besides production scenarios, the art no longer exists. It used to be an art because LLMs had a very small input context. So that was another thing, right? Like a year back, I only had maybe like 4,000 tokens, like in terms of the input window, maybe like a couple pages to get what I want the LLM to do. These days, we're going from like 4,000 tokens, input tokens, to like 128,000 tokens, right? So what that allows me to do is it allows me to just add an infinite amount of detail until I get it just right. Before, it's like I had like this much space to fit in this much information. That's where the art was. Like, how can I cleverly put these words in a way so that it fits in here and it gives me the output I'm looking for? All this to say, hopefully you found this useful. If you want to learn more about AI from a first principles point of view, from the base foundation level so you actually understand what's going on, check out my YouTube channel. I've got a first principles playlist for you guys. And with that being said, thank you guys so much for watching and have a good day. Bye.